Hi guys, we're going to do another chapter 5 video here today, and we are continuing to talk about is it a proportion? So this is something in our class we want to get down really well. And so let's talk about proportions again, and let's kind of review what we know. So there are some things we look for, and first off, maybe as a main idea over here, we'll write proportion. So there are three things I think of when I think of a proportion. First thing, I'll put a little star over here. The first thing I think of is it's got to be two equal fractions. I mean, that's technically the definition of a proportion. So the first thing I'm going to write down is two equal fractions. That is our definition of a proportion. But we can get a little more detailed about these two equal fractions. For instance, we can look at them in tables and we can look at them in graphs. So the second bullet point little star here that I'm going to write is when we look at it in a graph, it's got to pass through what we call the origin. So the line passes through the origin, which is at 0, 0 on the graph. That is kind of crucial. So we've got two equal fractions. The line has to pass through 0, 0. And I guess that's kind of the third bullet point is when you graph it, it better look like a line. It needs to be linear. So that is our third bullet point, linear graph. I'll just write linear. Linear means it looks like a line. So these are kind of the three things we look for when we're trying to determine if something is proportional. And we're going to try a few proportional examples today and kind of practice this skill set. So let's try our first example, example 1, and this is what we're going to write, example 1. Our question today is going to start with some information. So we're going to start with a table. This table shows a proportional relationship. This table shows a proportional relationship. Go ahead and pause the video if I'm going kind of fast and write that down and copy the table. And I'm going to put some numbers in this table. For x's, I'm going to go 0, 1, 2, 3. And for my y's, I'm going to go 0, 3, 6, 9. So those are our table numbers. Now, the table is proportional. They're actually already telling us that it is a proportional table. So that's kind of nice. So what do I know? If I graph it, it's going to be a line. It's going to pass through the origin through 0, passes through 0, 0, passes through 0, 0, which I can see in the table 0, 0, so that makes sense. But here's my actual question that I'm going to answer about this problem. And this is kind of interesting, so I'm going to zoom out a little bit so you can see this. The question is, can we find the constant of proportionality called r? Using the value for r, enter an equation in the form y equals rx. Now that might sound really confusing. Like to me, it even sounds pretty confusing. But this is what they're saying. When they say find the constant of proportionality, you might write this down in your notes and kind of pause the video. They're saying, hey, what's the growth? What's the pattern doing? That's what they're saying. And we've done this in class. We've practiced finding the growth in tables before. So that's all they're really saying. And when they say enter an equation y equals rx, they're saying what's the rule? What's the rule for our table? That's really all they're saying. So here's how I kind of tackle a problem like this. What I'm going to do is I'm going to be studying the table to figure this out. I'm going to go up to my table and I'm going to extend it just a little bit longer and put x in the bottom. And I'm going to try to figure out what is the rule? What am I doing to this number to turn it into these numbers? What am I doing? Well, I see the growth. It goes 3, 6, 9. So it's growing by 3s, going up by 3. And if I do 3 times 1, I get 3. If I do 3 times 2, I get 6. If I do 3 times 3, I get 9. So it looks like the rule is to do 3 times the x. It looks like we're doing 3x. We're timesing by 3 each time. Well, that kind of answers my question. Down here it says, well, find the rule. Well, it looks like our rule is y equals 3 times x, 3x. Our r value is equal to 3. So there's our rule. So all this all this question, all this confusing wording, find the constant of proportionality, use the r value and enter an equation, it's just saying what's the pattern doing? What's the growth number? What's the rule? And the rule is times it by 3. So we write y equals 3 times x. So let's try another one of these and kind of make sure you feel comfortable with this. We'll do an example 2. Example 2. And for our second example, we're going to have a similar setup. We're going to say, okay, we have a table that shows a proportional relationship. So the table is proportional. So they're already telling me it is a proportion. And in this table, here are my numbers this time. My x's are going to go 0, 1, 2, 3. And my y's are going to go 0, 4, 8, and 12. So I know that this is correct, that it's a proportion, because I can see that it passes through 0, 0. So that is a good sign right there. But that's not my question today. Since I already know it's a proportion, my question is one of these again. And again, pause the video. If this is going kind of fast, pause it and write everything down. So the question is, find the constant of proportionality. Find the constant of proportionality. That means, what is the growth? What is the pattern doing? What is our growth? What is our table going up by? 0, 4, 8, 12. It's going up by 4s, isn't it? It's adding 4 each time. I can see my growth number. So using the R, enter an equation in the form y equals Rx. Okay, R is growth. R is the 4. We know the growth. We figured out the R part. That part was easy. That was the growth number. What we got to do is write the rule. So we're going to extend our table. We're going to put x down here. And we're going to figure out, what are we doing to the x numbers to get the y numbers? What are we timesing it by? What is our R value? Well, we already know we're going up by 4s. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. So the rule is to do 4 times x. So that answers this question. Write the rule. Well, now we know the rule is y equals 4 times x. So when you see a problem about constant proportionality, what they're really just saying is, hey, can you figure out what's the pattern? What's it going up by? Can you write a rule? Y equals 4x. All right, so we're going to try a different type of problem now to kind of wrap up our video here just a little bit. And we are going to end with a final question that says, does the table below show a proportion? And we're going to call this example 3. Now in the last 2 problems, they told us, hey, this table is a proportion. But now the question is, does the table actually show a proportion? So in our table, we're going to have some numbers. We're going to do, x is going to be 5, 10, and 15. And y is going to be 30, 40, and 50. And the question is does the table show a proportion? So now I have to kind of go back to my beginning thoughts here for a moment. And my beginning thoughts were, proportions are 2 equal fractions. They pass through 0, 0, and they're linear. They make a line when you graph them. So to prove if this is a proportion, I have to kind of think about it a little bit. And one of my thoughts is, does it pass through 0, 0? So what kind of work could I show? Well, down below, here's going to be our work to prove our answer. My first thing is does it pass through 0, 0? I'm asking that question myself. I'm thinking, hey, does it go through 0, 0? Well, let's look at our pattern here. We definitely have a growth. Look at our growth. It's going plus 10, plus 10. So a very good pattern. So if I went back 10 from 30, it goes 50, 40, 30. I would get 20 if I followed the pattern. Over here, there's a pattern too. We're adding by 5s. So we definitely have nice constant growth. If I was to go back 5s, 15, 10, 5, it'd be 0. So the question is does it pass through 0, 0? And right here, I'm thinking in my head, no, it passes through 0, 20. No, it passes through 0, 20. And right away, this proves to me this is not a proportional relationship. If it doesn't go through 0, 0, it is not proportional. I'm going to write that. It is not proportional. It does have a nice growth number. It has this growing by 10. But if you work your way back, it does not go through 0, 0. So this is not a proportional relationship. So this is kind of one piece of evidence. I'll put a star by it. Here's a second piece of proof that I could do. Do we have room? Where are we going to put this second piece? Maybe we'll put our extra work over here. Put another star. Remember, a proportion has two equal fractions. So two equal fractions. Why don't I prove if this does or does not have two equal fractions? So let's pick some numbers. What do you want to use? You can choose anything you want, really. We could do the 15, the 10, or the 5. So how about the 15 and the 50? If I make a fraction out of that, that'd be 50 over 15. And if I chose like the 5 and the 30, and I'm just picking, that'd be 30 over 5. Are they equal? Well, in algebra, fractions mean to divide. So we are going to do 50 divided by 15. So let's check out what 50 divided by 15 is. 3.33333. Okay, we're going to write that down. It is 3.3 repeated. And 30 divided by 5, geez, I don't really need a calculator for 30 divided by 5. I know that one in my head. 30 divided by 5 is 6. These aren't equal. Slash that equal sign, not equal. So this is definitely not proportional, and I have a couple pieces of proof here. It doesn't go through 0, 0, and it doesn't have equal fractions. So if somebody said, can you write a response? Can you explain? I'd say, I know this because, if I had room to write, I know this because the x, y values do not pass through 0, 0, do not pass through 0, 0, and do not make two equal fractions, and do not make two equal fractions. I'm trying to write this nice. So if someone said, explain your work, what is going on here? This is what I would show is all of this. I would say, okay, it does not pass through 0, 0, goes through 0, 20. Does not have two equal fractions. I'd show some math. I'd make some proof. And I'd say a response. I know this because the x, y values do not pass through 0, 0 and do not make equal fractions. That is my evidence. So guys, that's going to wrap up this video, and I just kind of want to bring it back to two main ideas here. If you need to prove something is a proportion, you need to look for these things. Are there equal fractions? Does it go through 0, 0? And we didn't graph today, but you could draw a graph and plot the points and show if it's a line or not. That would be a good thing to add on here. Sometimes you're going to get these problems like the first couple examples that we did in our notes, where the table is already a proportion. They're going to tell you, and they're going to say, find this constant of proportionality, write the rule, y equals rx. So that's where you have to do the work to figure out the pattern. What is it being multiplied by? Y equals 3 times x, is it growing by 3? Y equals 2 times x, is it growing by 2? Whatever the growth number is. So I hope that kind of helps. We're going to keep working on this in class, and have a good day, guys. Bye.